There's certain words used when dealing with motion, and some of the words are automatically should indicate vector, some will automatically indicate scalar. So position is a vector term. The symbol X, Y, S, R, and so on. And there's another video out there where I go into some detail on that. There's not really a scalar equivalent, or shouldn't really say equivalent, the scalar analog for position. Displacement is the symbol used is just this, except with a capital delta, which means change. So it's a change in position. The scalar analog is distance. And the symbol, delta x, delta y, delta s, delta r. You'll notice that it's just this, except without the vector symbol. Velocity, the symbol, v with the vector symbol. Sometimes later on, if you're using v already, sometimes w is used and sometimes u is used. I tend not to do that till we get into, I think relativity is really where I first start dealing with that. The scalar analog is speed. So recognize this has a direction, this does not. And the symbol is just v. Please don't use s. Don't use d for distance. Don't use s for speed. Acceleration, the symbol with an a with a vector symbol over it. And unfortunately, the scalar is acceleration. The difference is the symbol used. And what I should do on quizzes and tests is when I ask for acceleration, put down the a with a vector symbol or a without the vector symbol. However, especially on the older tests and older quizzes, I have not done that. So if in doubt on a quiz or test, please ask. Typically, if it's not specified, this is the one that we're talking about, is the vector quantity of it. It'd really be nice if they had a different word for that, but there it is. Adding to the confusion here, if I want to know the magnitude of my velocity, magnitude of velocity is just, that's the symbol for it, and that's just saying, all right, you're going 50 miles per hour north at a particular moment, then the magnitude is just the 50 miles per hour north. Sometimes it is written as just a v without the vector symbol, which makes it confusing because now it is looking like speed. Now, the magnitude of instantaneous velocity is the same as the instantaneous speed. However, if you're talking about average, that falls apart. And so I will try to do this symbol right here when I'm talking about the magnitude of a vector quantity, putting the absolute value signs around it. However, I don't always do that. So just be aware, and if you get confused, please ask which one I mean. So just write down magnitude of instantaneous velocity. So magnitude of instantaneous velocity is instantaneous speed. Magnitude of average velocity, though, is not speed. It's not the magnitude of the average speed. Just a quick example there. I'm going, let's say, 100 meters and back in 10 seconds. 5 seconds one way, 5 seconds the other way. I go 200 meters in 10 seconds. This is my average speed. Notice no vector symbol there because this is the total distance traveled over the time. And so that would be 20 meters per second, about 45 miles an hour. 43 or so. My average velocity is my displacement over time. Well, I ended up back where I started, so therefore my displacement is 0 in 10 seconds. So my average velocity is 0 meters per second. Technically, it does have a direction. This is known as a zero vector. How well can that be seen? Technically, that's a zero vector. Zero vector is has a magnitude of 0 in whatever direction you want. So just a quick video on some of the vocab.